Okay, welcome students. Get ready to solve October-November 5054 paper 1 variant 2 of 2025 paper with TPS. And this is the very recent paper which we are going to solve. This is variant 2, multiple choice question paper 1. So in this paper, if you are going to take a value of G, you are supposed to take it 9.8 Newton per kilogram. The total mark of this paper is 40. So the first question is a micrometer is used to measure the diameter of a piece of wire. So remember for small objects or for the dia of wire, we need micrometer to measure its diameter. So this is known as main scale reading, and this is going to be a thimble scale reading. So what is the rule? What is the reading shown on the micrometer? What is the rule? First of all, you have to note down the main scale reading. Main scale reading is, you can see here till here, 5, 6, 7, and this is 7.5. And unit is milli. Now we have to see thimble scale reading. So thimble scale reading will be determined. First of all, you have to see the division here. Which division is aligned with this datum line? This line is a datum line. Remember, this is a datum line. And we have to see which division of thimble scale is aligned with this. So that is 25. So we have to multiply this 25 with least count, that is 0.01 millimeter. So when you multiply this, you will be getting 0.25 millimeter. So again, I repeat, first of all, for the thimble scale reading, you have to see which value of thimble scale is aligned with this datum line. So after recording that value, multiply it with least count, that is 0.01 millimeter, and you will be getting 0.25 millimeter. After doing this, you have to add main scale reading and thimble scale reading. So when you add this 7.5 plus 0.25, you will be getting what? 5, 7, and 7. So 7.75 millimeter, it is B option here. So B is right option for question number 1. Moving to question number 2. Two forces act on an object. 1.5 Newton acts vertically upwards. You can see here 2 Newton acts horizontally in this direction. What is the magnitude of the resultant force? So, dear students, whenever we are given two vectors, two forces, or two velocities in perpendicular to each other, so what we have to do, first of all, we have to use tip-tail method. Tip-tail method for its vector diagram. So, I'm going to project this vector 1.5 Newton here. Dotted line I'm drawing. This is 1.5. So now what you have to do, from the tail of this vector till the head of this is going to be the resultant vector. So this is the rule, tip tail method, or you can say head to tail rule. According to head to tail rule, join two vectors. Join two vectors and then you can find its result. So now it is a triangle. You can use Pythagoras theorem. You can take the square of 2 plus square of 1.5 and then take its square root. If you do so, if you calculate this, it will be 2.5 Newton. So B is right. Question 3, which equation defines acceleration? You know, acceleration is change in velocity with respect to time. So it is going to be D option, change in velocity divided by time taken. Then question number 4, the acceleration of free fall on the surface of moon is, on the surface of moon, again I say, is 1.6 the acceleration of free fall on the surface of the earth. So you can go back to the instructions. You can see here free fall acceleration is 9.8 meter per second square. So for moon, I am writing GM, that will be 1 by 6 of 9.8. So if you calculate this 9.8 divided by 6, you will be getting 1.633 Newton per kilogram. So what is the approximate weight of a 1 kg mass on the moon? You know W is equal to mg. So here you are going to take the value of this gravitational, you can say field strength of moon. So this is basically 1.633 meter per second square, and same is for the gravitational field. So W is equal to mass is in kg1, so 1.633, it will be 1.633 Newton. So if I round those value, it will be 1.6 Newton. B is right. For question number 4, B is right. Moving to question number 5. A ship uses ultrasound to measure the depth of the sea. Depth of sea. So suppose here I'm having a sea surface. Ultrasound rays are going to be dropped and it reflects back. So this is basically depth here, D, or you can say H is the height. So there is a time interval of 0.52 seconds. Time taken is 0.52 seconds between transmitting and detecting pulse. Detecting pulse means the pulse received. Okay. Speed of ultrasound in sea water is given 1500 meter per second. So this thing is indicating echo. Echo method is there. So what is the depth of the sea? So my dear students, we are going to use echo method. Speed is equal to 2d by t. So substitute the values. 1500 is equal to 2d divided by 0.52. If you solve this, it will be 1500 multiplied by 0.52 divided by 2. Actually, this is a ultrasound topic, or you can say topic of sound. In that topic, you have a topic ultrasound. This is basically regarding that, and in this you have echo method as well. So actually, this is a topic of waves. Question from the topic of waves. So 390 meter is answer. Question 5A. Question number 6. Which row shows definition of the mass? Mass is amount of matter in an object. So this is fine till here, but actual statement is that amount of matter or quantity of matter in an object at rest relative to the observer. Relative to the observer. So this is the appropriate statement. Remember this. So an instrument used to measure mass. Mass is measured by electronic balance, or you can say balance. So here you can see quantity of matter in an object and electronic balance is the instrument. C is right option here. So we are done with this question number 6. Okay, now we are on question number 7. Question number 7 says a quantity of water is poured into a measuring cylinder. A small piece of rock is then added carefully so that no splashing can occur. The diagram shows the water levels and the measuring cylinder scales. So in this measuring cylinder, you can say a piece of rock was added, and this is the new volume. So this is the volume of water. Volume of water. I name this as volume of water PW and volume of rock as VR. So what are the correct values for the volumes of water and rock? Okay. So dear students, you can see there is a gap of 10 and we have how many scales? 5 divisions are there. So one division is representing to 2. So it will be 32, then 34, and it will be 35. So I would say the volume of water is 35 centimeter cube. While if you see here, when rock is added, the volume of rock will be determined by total volume minus the volume of water. So now the total volume is, you can see here again, it is having a division of 2, so 52 and 54, 56, 58. So it is 59 somewhere. 59 minus 35. You will be getting 24. So for question number 7, the right option is going to be the C1. That the volume of water is 35, volume of rock is 24 centimeter cube. Moving to question number 8, which list contains only quantities that can be changed by force? So remember, force can change shape, size. If size is going to change, it means you can say volume is going to vary, and velocity. Velocity. So we have to see these three options. Mass, no, mass will not change. So A and B are C are not correct. Only D is correct. Shape, velocity, and volume. So moving to question 9, a resultant force acts on an object and causes it to move in a straight line. The graph shows how the resultant force varies with time. Which graph is the speed time graph for the object? Okay, dear students, remember if you see resultant force is decreasing with time. So if resultant force decreases, it means speed is decreasing. Speed is decreasing. And then you can see here what is happening. Time is still there, but force is going to be zero. It means acceleration is zero. If acceleration is zero, it means speed is constant. Speed is constant. So we have to see where the speed is constant. Speed is constant in this graph and in this graph. Here speed is zero, here speed is zero, so B and D are not the right option. Here you can see speed is increasing. Here speed is increasing with decreasing rate. Speed is increasing with decreasing rate. Decreasing rate means acceleration is decreasing. So if force is decreasing, it means acceleration is decreasing. So the speed is increasing with decreasing rate. So A is right option here. And if you remember, this is also representing to the graph of terminal velocity. Terminal velocity is same case as this one. Same story, same graph for the resultant force. So speed time graph is going to be the graph here of terminal velocity. So A is correct, not C. Moving to question number 10. An object is at rest on a table. So here you can see this is a table. Here is a object and it is at rest. The length of the arrows in the free body diagram represents magnitude and the direction of the forces acting on an object. When the object is on a table and it is in rest condition, so two forces are acting on it. One is its weight acting on the table, and one other force is in the upward direction, that will be normal force, normal contact force, normal reaction force, which is in the upward direction. So both are going to be of same magnitude. These forces are going to be of same magnitude. So which diagram shows the free body diagram of the object? So weight cannot be in the upward direction. So here the forces are not equal. So D, you can see weight is in the downward direction and contact force is in the upward direction. So D option is right here. So we are moving to question 11. Dear students, the load extension graph for a spring is shown. Load is on vertical axis, extension is on the horizontal axis. What does point X show? Very simple straight question. This is a point till which Hooke's law is obeyed. This is limit of proportionality. Limit of proportionality. After this point, what happens? It deforms permanently. Hooke's law is not obeyed. So B is right. Moving to question number 12. A car moves in a circle at constant speed. It is regarding circular motion. What is the direction of the resultant force? So, dear student, when an object moves in a circle, in a circular motion, here I am having object force, resultant force, or you can say centripetal force act towards the center. So, this resultant force will be pointing towards center. So center of circle turned by car is this one. It is highlighted here, is mentioned. So according to this, B option is representing a force which is pointing inwards. Simple straight question. Question number 13. A long plank is pivoted at its center of gravity. Here you can see a pivot point. Two objects X and Y are then placed on the plank. Two objects X and Y, X and Y. X of has a weight of 140 Newton and is 1.2 meter to the left of the pivot. Okay, you can see these readings. I name this as W1 and this is D1. Y has weight of 220 Newton, that is W2, and is 0.55 meter to the right of the pivot. This is going to be D2. So this is D2, this is W2. So they are saying a third object of weight 110 Newton is placed on the plank so that plank is in equilibrium. It means before placing this third object, it is not equilibrium. So on which part of the plank is the object placed? So dear students, see on which direction moment is smaller. Which moment is smaller? Which moment is smaller? Clockwise or anti-clockwise? Or you can say counterclockwise. So what I'm going to do, I'm going to find the moment here. So counterclockwise moment is equal to W1 D1. So it comes out 140 times 1.2. You can calculate this. You will be getting answer in Newton meter. Let me calculate 140 times 1.2. I am getting this 168 Newton meter. Now I calculate clockwise moment, this one. This is going to be clockwise moment and this was counterclockwise. Moment of clockwise is equal to W2 D2. You know the concept of moment. Moment is basically force times distance. So this is 220 times 0.55. You can calculate this. 220 times 0.55. It comes out 121 Newton meter. So the plank is at the moment in this condition that it is going to turn anti-clockwise. So clockwise moment is smaller, so I have to place other object, third object on the right side. So it should be placed at C. How you can find further? You can apply principle of moment to exactly find how much distance should be there. Why not D? Because if you place object somewhere here, greater moment will occur. So what I'm going to do, I'm going to apply principle of by principle of moment. What happens? Clockwise moment is equal to counterclockwise moment. So in this case, clockwise moment is going to be 121, this one, plus the weight that is of 110. I name it as W, and this distance D we have to find is equal to 168. This is anti-clockwise moment. So 110 times D is equal to 168 minus 121. So D is equal to, if you subtract these two values, you get 47 divided by 110. So if I divide these values, I am getting D is equal to 0.42 meter. So this distance is going to be somewhere here on the right side. So C option is correct. I hope so. This is clear. Now we are going towards question number 14. In question number 14, it's very simple, straight question given. Which statement about center of gravity is correct? So dear students, center of gravity says greater the base area, greater the base area, more stable the object, more stable the object. If lower the center of mass, one thing, and second is lower the center of mass or center of gravity or center of mass, more stable will be the object, will be an object. So see, is there any statement like this? Or center of gravity is the point where whole weight of an object acts. So object with center of gravity at same height are less stable when is larger. When base is greater, base area is larger, then it will be more stable, not less stable. This is wrong. Object with center of gravity at the same height are more stable when base area is larger. Yes, possible. Objects with higher center of gravity and smaller bases, no, wrong. Objects with identical bases are more stable when the center of gravity is higher. No, center of gravity should be lower. So B is right for question number 14. Moving to question number 15. Energy is stored in batteries, fuel, and food. So it is in terms of, you can say, atoms, ions, like this. So what is the name of this energy store? It is a chemical energy store. Simple question. Question number 16. A rocket has mass m when empty. Okay. Suppose I'm having this as a rocket, free body diagram, its mass is m. The rocket carries an additional mass m of fuel. Okay, additional mass. So I make this somehow like this. This is additional mass m. The rocket and fuel travel at speed v. So it is traveling with speed v. When engine of the rocket is fired, all of the fuel is expelled and speed of the rocket increases to 2v. It means now it is having just the mass of rocket. So when this mass is there, so it will be having a speed of 2v. So what happens to the kinetic energy of the rocket? So here if I find the kinetic energy, it will be kinetic energy is equal to half mv square. If I find the kinetic energy here, it will be half m and it is 2v, so velocity will be 2v and its square. So when you solve this, it will be 1 over 2 m times 4v square. So if I take out this 4 as a common, so what is left? 1 over 2 mv square. So this is basically kinetic energy. 1 over 2 mv square, this term is kinetic energy. So I would say it is 4 times of kinetic energy. So it doubles, no, it halves, no, it increases by a factor of 4. You can see this is a factor of 4. So kinetic energy increases by a factor of 4. 16 C option. Moving to question number 17. What is the definition of efficiency? Efficiency formula you have to tell. It is the ratio of useful energy output divided by total input energy. So C is right here. Moving to question 18, an object of mass m is lifted through a vertical distance d. So here I am having object of mass m. It is lifted in the upward direction. So this is the distance d. In time taken during this is t. So which equation is used to calculate the power required to lift the object? So, dear students, power is equal to work over time, or power is equal to energy by time. So here it is lifted, so we are going to use potential energy as our work, or you can say energy, which is equal to mgh. So mgh is distance, d, so it will be mgd by d. So we are having this option. Question number 18 is going to be B option. Hope so this is clear, dear students. Now we are moving to question 19. A block of wood is placed on a bench. Here we have a bench, block is placed here. The pressure exerted on the bench due to the block is 1 Pascal. So pressure of, you can say, pressure exerted on the bench due to block is 1 Pascal. The area of the block in contact with the base is A. Okay, area of block is A. Which statement is possible? So we know pressure is equal to force over area. Mass of block is 1 kg and area is 1 meter. So mass is not going to be there because I can see in option C and D weight is given. Weight is force. So the weight of the block is 1 Newton and area is 1 centimeter square. No, area should be in meter square and force should be in Newton. Force should be in Newton, area should be in meter square. Then you get the pressure in Newton per meter square or in Pascal. So force should be 1 Newton and area should be 1 meter square. So D is right here. Moving to question 20, different liquids are poured into different containers. Okay, in which container is the force exerted by the liquid on the bottom of the container is greatest? So here we have a container. In this you are having a liquid. So in which force exerted by liquid on the bottom of the container? Okay, here some force is going to act at the bottom. That force we have to calculate. So we are given with area, density, and depth. You know, pressure is equal to rho GH. One formula we know this. In this, area is not included, so we know pressure is equal to force over area. So we are going to equate these two equations. So it becomes F divided by area is equal to rho GH. So F is equal to rho GHA. So dear students, you can find the force by this way. So what you have to do, you have to multiply these values. This is area in centimeter square, density in centimeter cube, depth in centimeter, and you know value of G is constant. So if I multiply these values, for example, I take A option, it will be 10 times 9.8 times 1.3 times 50. You will be getting one answer. In the same way, you have to do this 20 times 0.80 multiplied by 80 multiplied by 9.8. You will be getting one answer. So what I look here that if I multiply, you can use a calculator. If you multiply this bigger value of area 50 with this density and here depth is also greater 75 and you multiply 9.8 here, you will be getting pressure here, oh sorry, force here greater. Means if area is greater and this will be greater, depth will be greater, density will be there. So if you multiply these options, you are getting the greater force here, greatest force here. So D is right. Actually, we are going to use this expression. Moving to question 21. A student compares the properties of three states of matter. Three states of matter are what? Liquid, gas, and solid. Solid, liquid, gas. The partially completed table in the student's notebook for one of the states is shown. State 1, we don't know. Arrangement of particle is random. Oh, it means either it is gas or liquid. Let's see. Motion of particle is moving freely. So it means it is gas. So state is gas. Forces between particles will be weak. Expansion when heated will be strong. So this is possible. Which word completes the table? So it is going to be B option. Gas, weakest and greatest. Simple question. Moving to question 22. Air is trapped in a glass tube by a liquid. When the tube is horizontal, the length of the trapped air is 50 millimeters. You can see here, it is 50 millimeters. And its pressure is going to be 1 expo 5 pascals. When the tube is vertical, this is vertical, with the closed end downwards, the length of the trapped air is 45 millimeters. The temperature of the air remains same. What is the pressure of the trapped air when the tube is vertical? So what is the pressure here? You know pressure that P1 V1 is equal to P2 V2. So I know that they are in same tubes. So just what happened that the area, cross-sectional area is constant here for both of them. Area is constant and length is given. So V is equal to AL. So I'm substituting this AL here in place of V1 and V2. So it will be P1 A, A times L1 is equal to P2 AL2. Area and area cancel because both of us are having same cross-sectional area. So pressure is given for one, that is this one, P1, I name it as L1. So 1 times 10 power 5 times 50 millimeter. Okay, this is also in millimeter, so keep it as millimeter. Pressure 2 we have to find, and this is 45. So pressure 2 will be 1 times 10 power 5 multiplied by 50 divided by 45. So you will be getting the pressure if you calculate here in pascals. And what you get for question 22, if I calculate it, you will be getting 1.1 times 10 power 5. So it is C option. So hope so, dear students, it is clear. Okay, students, now we are on question number 23. The diagram shows two changes of state X and Y. So in you can see here from a state of gas to liquid, when we go, this process is known as condensation. Condensation, spelling mistake. This process is going to be named as condensation. And when liquid to solid we go, that is freezing. But you see here the arrow is from solid to liquid, so we are going to consider this one. This is melting. When solid is going to be heated, it is going to melt and then it changes to liquid. So according to this, X is going to be a condensation and Y is going to be melting. So 23D option is right. So now students, we are on question 24. Energy can be transferred by thermal radiation. Four surfaces have different colors and textures. Whenever there is a going to be a part like colors and textures, remember it means some good absorber is good emitter as well. Good absorber is good emitter as well. Somehow the story is going to be like that. Good emitter as well. So this is thermal radiation. The surfaces are at equal temperatures and have equal surface areas. Which surface transfers energy by thermal radiation at fastest rate? So remember that dark color absorb energy more and they emit energy more as well. So dark color is going to be the fastest rate, and dull surface also. Dull surface. Shiny surface is going to be a reflector, so it is not going to be a good absorber and good emitter. In the same way, light colors, dark colors and light colors, they are also not going to be a good absorber and good emitter. So here fastest rate is going to be for dark and dull surface. A is right here. Black and dark is going to be here black color. Black and dull surface. Black and shiny. Shiny is not possible. White is not possible. White and shiny is not possible. So remember that dark color they have given, that is black, and dull surface is going to be the fastest rate. So moving to question 25, four copper spheres have identical surface colors and identical surface textures. They have different surface temperatures and surface areas. In previous question, surface area and temperature of the surface was same, equal, but now the spheres are going to have different surface temperature and different surface area. So, but spheres are identical. So, which sphere emits infrared radiation at greatest rate? So, we have to calculate here that where energy is going to be more. So, greater the area and greater the temperature, you know that uh, sphere is going to have greater ability to absorb more radiation, good absorber and good emitter. Again, the same story we have to remember. But here, if any object is having greater area, it can absorb more energy. More area is there to absorb energy. And its temperature is going to be more. So, more the temperature, more radiation, more heat will be emitted. Greater the area, if greater area is absorbing too much heat, so greater area is also emitting too much heat. So I would say that the greater temperature is 1000 and surface area is 480 centimeters square. So D is right here. If I'm having a smaller sphere, suppose like this, it is going to have less temperature. Highest temperature will be smaller here as compared to the temperature which this bigger sphere will be having. So we have to consider about this thing. Question number 26. The table shows the speed and the wavelength for different sound waves in different materials, four different materials. Which waves are ultrasound waves? Okay. You know, ultrasound waves are the waves which have frequency greater than 20 kilohertz, which is not audible to human healthy ear. So we are given with speed, we are given with wavelength. We know V is equal to F lambda. So F is equal to V over lambda. We will be calculating this frequency for each option. So one by one, you have to calculate this and where you will be getting the highest frequency. I think here the speed is greater and wavelength is smaller. So my answer will be bigger. So 4000 divided by 0.23. So if I calculate this, I am getting the frequency. Let me calculate it. 4000 divided by 0.23. I am getting approximately, you can say, 7400 hertz. If I calculate this one, 340 divided by 0.19, the answer will be smaller. Speed is less and wavelength is also smaller. So I am getting this 1780 hertz. So this is very small value. You can calculate this frequency in the same way. So 1500 divided by 0.050. Okay, I am getting 30 kilohertz. Means 30,000 hertz frequency is here. So in the same way, you can calculate for this 6700. This is much higher speed. So wavelength is 0.31. If you calculate this, it is 6700 divided by 0.31. So I am getting this 121,600 hertz. So this is also greater than 20 kilohertz. This frequency is also greater than 20 kilohertz. So option 2 and option 4. So according to this, 2 and 4 C is right. So again, I repeat that you have to use this formula and calculate for each option 1, 2, 3, 4 waves, 4 different waves. Now question 27, light passes into transparent material that has a refractive index L. The angle of incidence at the surface of the transparent material is I. Which equation is used to calculate angle of refraction. Light passes into transparent medium. It means we are going from less dense to dense, less dense to dense. So n is equal to sine I over sine r. One thing is this, so we have to find angle of refraction. So the possibility is sine r is equal to sine I divided by n. So this option we are having, it is D. Question 27, D is right. Then moving to question 28, which diagram show a ray of light that is reflected by a plane mirror? Reflected means the ray will move in the same medium. Ray will move in the same medium. Here refraction is occurring. Here refraction is occurring. Here also refraction is occurring. Here reflection is occurring, but not according to the law. Law says angle of incidence should be equal to angle of R. So in D option, you can see angle of I is equal to angle of R. So D is right option here. Moving to question 29, an object is placed in front of a plane mirror. So suppose this is a plane mirror. Here is object. Which statement describe the image produced? So remember, if the object is having distance D from here, this is object, image will also be in the same distance behind the mirror. So at the same distance, image is going to be located. Image will be this one virtual, and it is going to be of same size. Virtual image, same size, same distance from the mirror, same distance from the mirror. So you have to see either any option like this is there. So real, no, B, A and B option are wrong. Virtual and smaller, no. Virtual and same size as the object. So D is right option here. Now we are having three rays of light are incident on the boundary between glass block and air. It means dense to less dense. The ray is moving. Dense to less dense. The angle of incidence are different. What is possible critical angle for light in the glass? Possible critical angle. So critical angle we have to tell, okay, here refraction is going on. This angle is little increased, it becomes 40 degree. Now again refraction is occurring and the ray is bending to away from the normal line. Here reflection is occurring, total internal reflection you can say. So between these two angles might be 45 degree or between 40 and 50. When angle is going to be this one, the ray is going to bend on the boundary. So 15 is not possible, 30 is not possible, C is possible, and D is greater than this, so it is also not possible. Critical angle is when angle of refraction is 90 degree. Okay, now we are on question 31. A student does an investigation using four thin lenses. The lenses are used to produce focused images of four different objects. The student measures the length of the image, okay, length of the image and length of the object. So this thing is indicating that might be the student is going to focus for linear magnification or you can say for magnification. The results are shown in the table. In which case is the magnification produced the greatest? Yes. So you have to remember that magnification is equal to length of image. It can be height of image as well. Length of image divided by length of object or height of object. So you have to use all these four options and where it is going to be the bigger value for M, that is going to be the greatest magnification. So one way is that if image height is greater and object height is smaller, you will be getting the bigger value there. So if you see, let's calculate 3.5 divided by 0.8. You will be getting here 4.3 or 4.4 you can say. I have rounded the value. Then 4.7 divided by 0.6, you will be getting 7.8. Then you have a value 4.8 image length. Unit should be same. Yeah, it is same. And divided by 0.7, this is 6.9, you can say. Rounded value I'm giving. Then 5.2 divided by 0.9. So you are getting 5.77. So 5.8 you can say. So B is right here. The value is bigger. So magnification when the image length is 4.7 and object length is 0.6, your magnification will be the greatest. So moving to question 32, magnets M1, M2 and M3 are joined by iron balls. These are the magnets and these are the balls W, X and Y. Magnetic poles are induced in the iron balls W and X. You can see here W, here south, here we have south pole, here we have north, here we have south pole. Okay, which diagram shows the poles induced in ball Y? Okay, so we have to tell about this. If this end of the magnet is south, so here it will be having north. The other end will be the north. And here the magnet is having south pole, so here the magnet will be having north pole. So the ball is having north and north poles induced, so B is right. Easy question. Question 33 now. A cardboard tube has two wires, P and Q, okay? Connected to its ends inside the tube, wire P and wire Q are connected to two resistors. Okay, very good question it is. Inside the tube, somewhere here, wire P and wire Q are connected to two resistors, means in this tube, two resistors are present. In the tube, inside the tube, two resistors are present, are connected. The potential difference between P and Q is 9 volt. Okay, so the voltage which you are getting here, if you connect the voltmeter, that is 9 volt. And the current in the wire is going to be 0.75 ampere. So these two quantities are given. We can find the resistance R is equal to V over I. So if you divide this 9 divided by 0.75, you will be getting 12 volt. Which combination of resistors is inside the tube? Okay, so we have to see either it is going to be two resistors connected in series or parallel. In series, what happens? You add the two resistors. In parallel, you add the reciprocal of the two resistors and then you solve for the total resistance. So if you solve this parallel for 0.75 and 6, you will be having the value 0.75 plus 1 over 6, which will be equal to 1 over R total. Actually, if you calculate these two, your answer should be this one. So if I calculate 1 divided by 0.75, will be 1.33 plus 1 divided by 6. The answer is 0.16. So if I add these two values, I will be getting 1.5. So actually I have to find the R total. So I will be taking the reciprocal here. R total will be 1 over 1.5. So 1 divided by 1.5, I am getting 0.66 ohm. So this is not the possible option. A is wrong. 0.75 resistor and 6 ohm resistor in series. So you add them, you will be getting 6.75 ohm. This is also wrong. D option says the 20 ohm and 30 ohm resistors are connected in series. If you add them, it is 50 ohm. So this is also wrong. The remaining option is C. I hope so. It will be C. And it will be definitely C because all the three options are wrong. So how we can justify this? You can calculate this 1 over 20 plus 1 over 30 because in parallel circuits resistance decreases. So greater value of resistor should be connected. Then you will be getting the smaller value. 1 divided by 20 plus 1 divided by 30. Okay, dear students, we are on option C. That option C is right. So what you can do, 1 over 20, if you solve 1 over 20 and then add in this 1 divided by 30, you will be getting the answer 0.083. So you have to find the total resistance. You take the reciprocal of this, 1 divided by 0.083. The answer will be 0.083. It is 12 ohm. So C is right option. C is giving you 12 ohm if you solve this. Moving to question 34. A resistor of resistance R, here it is connected to a variable resistor, a voltmeter and a power supply and EMF. The resistance of the variable resistor increases from 0 to 2R. Okay. What happens to the reading on the voltmeter? It would decrease. If you see here, in this way they are connected. Let's see what happens. Here we have to find the voltage. This is a variable resistor. This is fixed resistor having resistance R, and variable resistor can have a range of this 0 to 2R. So let's suppose I do R this. So I'm having EMF E. So what happens? Same resistance. So the voltage drop will be same. It will be, you can say, half E by 2 here, E by 2 here. Because this circuit is having a ratio 1:1 because R and R. Ratio is 1, here it is 1. So total ratio, sum of this is 2. And how much you can say potential drop will occur here? It will be 1 by 2 of E. Now, if I increase from 0 to 2R, it means that this is fixed and the variable resistance is now having 2R here. It means 1:2 it is going to be. So total is 3. And here, how much voltage will be? You can say 2 by 3E. So in this way, we can find out. So it will be C option here. For question 34, C option is here. It is little tricky question, little different question. You can use this assumption of ratios as well. Other way around, you can do other way that here it is going to be now more voltage drop. Here it will be going to be different. Because in series circuit current remains same. So anyhow, moving towards another question. Sorry, here the voltage will drop will be less. Here it will be greater because its resistance is going to be greater. So V is equal to IR. You can use. Question 35. Which device works due to electromagnetic induction? It is a transformer. So D is right. Question 36. A beta particle travels to the right at constant speed. So beta is having which charge? Negative charge. It is going in this right direction. So which field detects the particle towards the top of the page? Okay, top of the page. So somewhere here you have a field. We have to identify either it is going to be into or out of the page. So using Fleming's left hand rule, you can identify this. Fleming's left hand rule. So if it is negative charge, it means current is going opposite to this because current flows from positive. And Fleming's left hand rule says that all the three fingers, thumb, first finger means index finger, and middle finger, they should be at 90 degree, middle finger. They must have 90 degree with each other. So force should be acting to top of the page. So I need force here. So we have to tell that field will be into the page or out of the page, into the page or out of the page. So dear students, you have to follow this, that current is going to be represented by middle finger. Your middle finger should be, your second finger should be towards left side. Thumb should be upwards because thumb represents force. Thumb represents force. So you have to arrange this in such a way that current means, again repeating, middle finger should be left, thumb should be upwards. So magnetic field is represented by index finger, that will be towards you. It means out of the page. So here we are not going to use cross. Here we use dots. Dot represents out of the page. out of the page. So when this charge will come in this field, it will go like this upwards. So it will be out of the page, a horizontal magnetic field directed out of the page. A option is right. You have to use Fleming's left hand rule. You can use this indication that field is towards you, force means thumb is here upwards. This is force. This right side, oh sorry, left side will be current. That is going to be second finger, or you can say middle finger. And this is towards you, that will be index finger. So very simple question. You have to remember the rule. Which nuclide notation, it is basically nuclide, is produced when thorium 223 emits an alpha particle? So when alpha decay occurs, nucleon number decreases by 4. Nucleon number decreases by 4 and proton number decreases by 2. Proton number decreases by 2. So 223 minus 4, you will be getting 219, and proton number you will be getting 90 minus 2, that will be 88. So we need this combination. So C is not giving, D is not giving, here it is 92, no, A is only right. So it means thorium changes to radium after alpha decay, or when it emits alpha particle. So alpha decay is basically a thing. So now we move towards question number 38. A radioactive source is placed 2 centimeter away from the GM tube that is connected to a counter. Okay, so you can say here we have a GM tube. This is a GM tube. Here we have reading or counter. You can say a sheet of paper is placed between the source and the GM tube. So here we have a source, and somewhere here sheet of paper is placed. The count rate measured by the counter decreases to a value greater than the background radiation. It means some background radiation is there. Background radiation is there. Suppose that is 30. And when this sheet of paper was not there, the reading here it is 80. When this sheet of paper is placed, suppose it becomes 50, greater than background radiation. Aluminium replaces the paper. Okay, now this paper is replaced with aluminium, sheet of aluminium. The count rate decreases to the background radiation. It means now this 50 is not equal to 50, it becomes equal to 30. So aluminium is used to block beta particles, and sheet of paper is used to block alpha particles. So what is the radiation emitted by the source? So I have told you alpha and beta. So it is going to be B option, alpha particle and beta particles only. So B is right. Which statement about the Earth is correct? Okay, it has an elliptical orbit around the Earth. Yes, true. It is a star. No, it is a planet. It rotates on its own axis. No, 24 hours. This statement is wrong. It is actually 24 hours. It orbits moon. No, moon orbits the Earth in once a month, not once a year. So A is right. Question number 40. A student asked two students to describe redshift. Okay, redshift is when wavelength increases. Wavelength increases when objects, astronomical objects, I would say, astronomical objects move far away from the Earth. So let's see. Student 1 says it is a decrease in the observed wavelength of electromagnetic radiation from the stars. No, it occurs because stars and galaxies move away from the Earth. Yes. Possible. This student 2 is right. Which students are correct? Student 2 is only correct. 40 will be C. Dear students, we are done with this paper. This paper is the very recent paper, very interesting paper. Some new questions were there, and we are done with this. If you face any difficulty, any question which is not clear to you, you can discuss that with me. You can make a contact to me. So hope so it is clear. Take care, stay blessed.